The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Chem 1025's Exam 2 Spring 2010, number 9. It says, the following reaction is used to obtain iron from iron ore. So here's the iron, and we're getting it from the iron ore. The reaction of 167 grams of hematite with 85.8 grams of carbon monoxide produces 72.3 grams of iron. Determine the percent yield, assuming that carbon monoxide is the limiting reagent. So, that last statement, assuming that carbon monoxide is a limiting reagent, saves us a lot of time, actually. So, let's do a little dance, because your professor threw that in there. It's very nice. Okay, we know that we're going to have to base our information off of carbon monoxide, since it runs out first. That's what's meant by limiting reagent. So, this 167 grams of Fe2O3 plays really no part. I mean, some of it gets used up, but some of it's also left over. The leftover stuff we're not worried about. Since we have excess of this, I'm not concerned with how much I have. I just know I have enough to completely react away all my carbon monoxide. Alright? Percent yield. So, how does percent yield work? Don't look at my holy moly world yet. We'll get there in just a second. Percent yield is when you are in the kitchen making some really good cheesecake, and you have enough ingredients to potentially make like 10 cheesecakes because you really like them. It's all for you. But your brother comes by and steals one of your cheesecakes, partially made, sticks his hands in it, and you drop some cream cheese, and you found out your milk is bad and things like that. You only end up making 6 cheesecakes. Theoretically, you could have made 10, though. So your percent yield was only 60%. So it's how much you actually made divided by how much you could have made, your theoretical. So what you actually made versus your theoretically made. And then you're just going to multiply by 100% in order to turn it into 2%. So let's write up the percent yield for this reaction. Percent yield of Fe. That's what the problem was. We found out that we actually made 72.3 grams Fe. We're going to multiply by 100%. But what do we put as how much we theoretically could have made? We know that we're going to have some sort of mass to go down here, grams of Fe, because the numerator is in grams of Fe. But we need to calculate the theoretical amount. Again, it's going to come straight from the carbon monoxide amount, since this is what runs out first. I don't care about this. In fact, so let's do this. Assume that I had say I had 3 moles. This is a chemical equation that relates the moles of everything to one another. So if I had 3 moles of carbon monoxide, I would react it with 1 mole of Fe2O3, and it would give me 2 moles of Fe. What if I had 6 moles of CO? Then I could potentially make 4 moles of Fe, right? And if I had 1.5, I could make 1 mole of Fe. So it's always in this 3-to-2 ratio. That way, I can turn my grams of carbon monoxide into moles of carbon monoxide, and then use that ratio to eventually get grams of Fe. Better explained is this little ditty into holy moly world. So here we go. We're jumping. We're spinning. Here we are. We are currently in grams of carbon monoxide, which is up here in mole world. Right? Mole world says I can't just straight convert between grams of 2 things. I have to go the long route. I have to connect them by their moles. Alright? So I need to take my grams of carbon monoxide, convert it into moles of carbon monoxide. Then I'm going to take my moles carbon monoxide, convert it into moles of what I'm looking for, which is the Fe. Then I'm just going to convert to grams Fe and plug it right in here. And that's the theoretical amount. So I have 85.8 grams carbon monoxide. I'm going to copy down my units that need to get canceled, which are grams CO. Mole world tells me convert to moles of CO. Okay, I'll listen to you, mole world. In 1 mole of carbon monoxide, according to the periodic table, there are 28.01 grams of carbon monoxide. Continuing the conversion, since grams of CO canceled, I'm going to put moles of CO on the bottom. Looking at mole world, I need to go from moles of one thing to moles of another. I'm looking for moles of Fe, eventually. So, how do we do that? Moles CO to moles Fe. It's a 3:2 ratio. 3 moles of CO for every 2 moles of Fe. Moles of CO cancel. And finally, if I'm at moles of Fe, I can get to grams of Fe. So I'm just going to put moles Fe down here to cancel. And I need to put grams Fe up top. What is that ratio? We look at the periodic table. For every 1 mole of Fe, there are 50... Let's do that. 55.85. 55.85 grams of Fe. Let's clean that up a little bit. Erase that for now. Okay. Punching all this out, multiplying by everything on the top, dividing by everything on the bottom, we get 114.05 grams of Fe. And that's the theoretical amount. So I'm going to plug that amount in right here. That's how much I could have made, but something went awry somewhere along the way. Finally, 72.3 divided by 114 gives 63.4% yield. Don't forget to multiply by 100.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.